Hello and welcome to IT Security Labs. My name is Howard and today we're going to be looking at the game of Active Directory. This is going to teach us how to enumerate Active Directory, how to defend against Active Directory attacks, and specifically today we're going to focus on access control on group policy objects. So we'll start by defining what group policy objects are, how an attacker might identify them, how we can detect if there's any traffic that's coming in our environment, and I'll actually show you some of the alerts that might fire and also some of the traffic that you might be able to see. And then we'll maybe talk about some mitigation strategies. So this is a information-packed hands-on lab that we have, and you can set it up yourself as well by following this series. But I can also show you what we're going to be doing here in a second. If you're brand new to my channel, the game of Active Directory is a lab that we set up in this series, and it's by Mayfly. And Mayfly came up with this lab, and I'm just borrowing from them, and all the credit goes to them. But a simple network diagram looks like this for my setup. I'm using OpenSense Firewall. It's supposed to be a next-gen firewall. I was going to use it for other features as well in future videos. And then we do have our Kali here machine. It's on the same network this time. This is an assumed breach kind of demonstration. And we do have two domain controllers, DC1 and DC2, and three servers. Actually, two servers in this case, server 2 and server 3. These machines are configured with Sysmon and Elastic agents, and these Elastic agents are sending data to our Security Onion SIEM environment. This is the same as the Kali Purple, just slight difference because in Security Onion, we're now using some playbooks that I'll show you in a second. Otherwise, this is a very, very good lab, especially if you just want to see what happens in an environment, what kind of data are we sending when we're doing capture the flags and things like that. So with this in mind, we also have my Kali Linux machine ready to go. And I'm just going to get started with what is a group policy object? Why do we care about them? Because we'll be actually looking at them and the misconfigurations that they have. Here's an article from waldo.com, which I think is really good. So please check it out if you want. But in a nutshell, when I was a system administrator, if I wanted to deploy a new password policy, for example, and change it on all domain joined computers, I would most likely use a group policy object that says on the computer, if someone is to sign in, expect them to provide a password that is 15 characters long or whatever the policy was. And also the password expiration policies were being pushed using these tiny little files called group policy objects. They can be applied to users, they can be applied to computers, they can be applied to objects like printers. Any AD object can actually be added as long as it's part of an OU that you can link or enforce a policy on. So group policy objects are just tiny little files in Windows that have instructions, specific instructions on how a user, a computer, or any other Active Directory object should behave. Like, what do we expect a user to have? One simple example that you can think of is if you don't want your users to be changing, let's say, Windows Defender and disabling and enabling your firewall, you can push a policy that says the users shall not change real-time monitoring on a computer. And if they try to change it, it will either not be there or it will just won't let them there. Given that much power and control that group policy objects have in Windows, it makes sense that attackers are also interested in them. So in our case, we have our game of Active Directory. We don't know what's going on in this environment. Let's assume we have nothing, but we know that we have IP addresses we're given. So this is a white box pen test. And we know that we can find out how to get in one of these machines. And once we find out how to get in these machines, we can also run something like Bloodhound to collect some data to know about every object that's in a AD that is speaking back to us. So in this case, let's go to our attacker machine, and we'll just start by doing a simple net exec. This is a crackmap exec. And I'm doing this so that we have a almost close to realistic way of showing a password and how we got it. So in this case, netexec is going to scan our network using SMB without any authentication. In this case, we're scanning one of the domain controllers called Winterfell, and we just want to list all the users. In this case, just tell me who are the users that are there. Lucky for us, one of the users has a password in the description field in Active Directory. This is very rare. You don't expect to be seeing it, but in this case, it's an easy way for us to show initial access. Now that we know that we have Samuel here with a password of Heartburn, what access do they have? The next part will be you need to go maybe try to sign into the systems and see if you can get there. I already did that in previous videos, that you can sign into one of the domain controllers. So we're just going to use this password to move forward. But before we start using this person's password, let's revisit the data that we dumped in our previous videos from Active Directory. What access does Samuel Tally have? Maybe that's a good place to start. So let's grab that. And I already launched my Bloodhound. If you want to know more about this, I have a video that I'll link that will show you how to run Bloodhound and correct this data and end up where I am here. So we can just search for Samuel. What do you have? Okay, so clicking back on the outbound here, we notice that this person has a generic right and is owner of this stack wallpaper.north here. What is that? That's a group policy object. So if I click on it, it will show me like, okay, this is actually is owned by Vagrant, which is our local admin account, by our user that we found in the description. Okay, and they have pretty much right permissions. Bloodhound might even tell us how we can abuse it, but in this case, we know that we do have access to stack wallpaper group policy object and that we own. So how do we go about looking at group policy objects and also abusing them? I do have some notes, and also I'm following along from Mayfly's documentation. So I'm not actually coming up with anything original here. So if you want, you can just follow along with the same documentation. I'll just add some context as I'm talking about it. But the first thing that we will probably want to do is set up GPO abuse. So what is this thing here? Let's go and find it. There are a lot of tools out there that you can use for abusing group policy objects, and this is just one of them, and it's the easiest one that we are going to be using. The most common one will be the sharp GPO abuse, and I did not want to upload a binary to the machine today. In a different video I can, but this one is a .NET application that was created by FR Secure Labs, and in this case, you can actually use it to interact with group policy objects. Remember, our group policy objects allow us to control a bunch of computers, users, or other devices, objects in our Active Directory environment. So what can we do? We can tell group policy to add a user, like a brand new user, to any computer that the group policy is applied to. In this case, we have a wallpaper policy that is applied to a bunch of computers. So we can say, instead of changing the wallpaper, how about you also add another user to each computer and make them a domain admin or a local admin. You can also maybe modify an existing user. If you knew other users on those computers, you can get a reverse shell, which is easier. So this is the original one. I'll probably be using this one again in a different video. This one also works with execute assembly in Cobalt Strike, so that's probably something that will make it more appealing for most people. Here, we're going to be using the Python implementation of it. And this one, we just run it straight from Kali Linux, and it will send data over the wire to Active Directory using our user. Let's check the Python script before we do anything else there. This will be a very quick way of doing it. Okay, so it's going to be using impacket. It's just like impacket, the actual impacket field, and it has a lot of features built in here. One of the things that I found out is that it will sign into the domain. If you give it the group policy object ID, this one does not take the group policy object name, it takes the ID. Then you can actually go and modify the group policy object. So how do we do that? Well, first, we need to clone this repo to our machine. So what we can do is, I already have some pastables here to save us some time. We just need to copy that repo. In my Kali attacker machine here, I'll just make a directory called GPO, cd GPO. Okay, because I already did this, I want to show you how you can do it. So git clone that repo. Then go to the GPO abuse. And in here, we do have our Python script that we were just checking out earlier. Okay, so now that we did that, I like the way that Mayfly suggests. Let's create a specific Python environment and then activate it and install the requirements. That way, we know that this is actually isolated from the rest of our computer and it does not break our existing IM packet. So this is going to install a Python environment, activate it, and install all the requirements. That includes the IM packet stuff that it needs. So this doesn't take a long time. And you can find these instructions right here. And I'll link to this page here as well. All right, so once we have our environment ready, what we now need to do is we also need to clone another tool called GPO Onion.git if you wanted to, but I can show you a different way as well, because we need to know the group policy ID number. In our sec, though, we're using Bloodhound, so we can go to Bloodhound, find out that this is our group policy. We need to find out what is its ID. It should be somewhere. Object ID, right there. We are going to need that. So once you copy your object ID from Bloodhound and you put it right here, the next thing that we need to do is make sure that we run our script. By the way, if you want to find the group policy object ID, another way you can do it is to run this tool called gpond.py, and you can find it online. That's a second way of finding out the group policy ID. And every time you run these, you're sending traffic over the network, by the way. So you will need to consider that as something else as well. So I downloaded GPOnd. You can find it online. And I'm just giving it the credentials. This will list our group policy objects that our user has access to. GPOnd. Let me move myself again. I'm getting evicted. All right. So Python GPOnd, the user, the password, the domain, then the domain control IP address, and then here we want it to list the group policy objects. The stack wallpaper group policy object is here, and here is its name, in this case group policy ID, which will also match what was in Bloodhound if you ran your Bloodhound in the same instance. So now that we have the group policy ID, next we need to make sure that we run our script, and this is where things get interesting. So in order for us to utilize our access to a group policy object that we own, one of the things that we can do is, like I said, we can add a new user and make them a domain admin. Well, this GPO abuse.py comes with that pre-built in. It adds a user called John, and the syntax is Python 3, call the script, give it the domain name, / the name of the user, and then colon the password. You say, hey, I want you to modify the GPO ID of that. If you don't give it any other parameters, it will add a user called John for us. So if I copy that and come here, and this time we just want to run our script, but we need to run it in our real environment here, where we have it in the environment and also all the requirements are met. So this is going to run. If there is already a scheduled tasks.xml file, this will create a scheduled task that is supposed to run immediately. So what we can do is we can just do a -f. -f will just append to the existing scheduled task. This is happening because I ran it before I started recording. That's why. Otherwise, the first time it won't do that. Then you say, oh, scheduled task is created. So what did we just do here? We sent over the wire to the domain controller. I already have this name in my Etsy host. So my Etsy host already knows this domain information. I added it a while ago. That's why we have it here. It's a mess, but that's how we did it. So we sent that command and we said, hey, go and create a user for us. A user was created. So let's go to the actual domain controller that we are modifying to check it out. So let's first open the command line and type net user. The user that was added is this John user here. That's by default. That is by default. If you look at the documentation for the tool, it adds that user. So right away, red flags, right? This was very intrusive. We literally went to the machine and we said, let's create a user. What do you think our intrusion detection system is going to do? It's really going to figured out that somebody did that. So let's look here. Let's just refresh. Let's see if we can see that John was added. So if you look in some of these events, a user added to local administrator group. Oh, that's interesting, especially on a domain controller. Like if I was still a system administrator, I'll be watching who is adding users, local administrators group. So this is actually reasonable. User created via NetExe. That's another alert, which is interesting. So we already know that a user was created with using this. So let's drill down in this alert. This is just Security Onion playbooks. What was the name of the user? I bet you money that this user was John. Let's look at the actual command down here. I don't know if you can see this clearly. Net user John add, and the password was this HX00 stuff that's up there. All right, so I just zoomed in for us here so we can see clearly the user was added. That's in our Security Onion. We are using sysmon. This is actually coming from command line. So that's a sysmon log that we have there. Maybe I might be wrong there, but I have sysmon sending all kinds of things to my events. So now that we know that just the mere idea of adding users can get you detection, maybe that's something you should have in your domain controller. If you're a red teamer, maybe this is something you shouldn't be doing, adding new users to a domain controller, unless you really want to get busted. Either way, this is a good learning opportunity for us, figuring out, okay, we know what Active Directory does, we know the GPO, we know we can run a script. Now we know that it also shows up there. We have other alerts as well. We added that user to a group, so there should be another alert that says a new user was added to the domain administrator group, as you saw. So just a little bit intrusive, I would say, the action that we did there. Oh yeah, the user was added to the local administrator group. So this should be the net local group add user to administrators. So let's just find it. Oh, look at even the command line would show us that it used the scheduled task. So we know somebody did a scheduled task, but the command was net user John in that password and add them to the local administrator group. Right away, this is the same detection. It doesn't have anything to do with GPOs as such. It's just every time a user is added, this will actually happen. All right. So now that we know we added our user John, let's find out if we can use EVE-WinRM to sign in. I mean, we're already doing bad OPSEC anyway. Let's use EVE-WinRM here. Let's get in. So we're going to say, hey, EVE-WinRM, we got our user John and their password. Can you please sign into that machine? In this case, we're going straight to the domain controller. John was added as a domain admin. So who am I? Let's do all the bad things. Net user John. John is part of the administrators and was added. You see, the date is right there. We now know that we're in. By the way, using EVE-WinRM to get in, you can also leave a lot of evidence. Running who am I will get us busted. So let's go back to our intrusion detection system. You notice that we have a who am I utility that was ran from unusual source or something. Let's see. Yeah, this one. Who am I utility execution. But there was another one that says actually from, ET hunting. Who am I command inbound on high port. That's a different one. But the one that we want to talk about is the who am I utility execution. So let's check it out. Does this one actually say John? Who am I itself is not bad, but if on the same machine we see a scheduled task was created, a user was added, and they ran who am I, that's very suspicious and interesting. And in this case, this was ran from C users John documents. So this is John, again, running who am I. So now that we know those two actions get us caught, what if we wanted to get a reverse shell? Maybe you're going for the OSCP, OSEP, one of those CTFs, and you just want a clean reverse shell because they want you to get a reverse shell. Well, let's do that. Mayfly showed us here how to get a reverse shell. We just need to rerun the same thing, and we're using PowerShell. Let me show you the one that I copied and what I added. Maybe we can modify. I'll show you what to modify. So we're going to run the GPO abuse again with the same north and also give it the group policy ID. This needs to be what you found in your Bloodhound or using the other two that I showed you earlier. So you definitely need that. Then for the PowerShell, we're just using straight PowerShell to make a network connection back to us. And in the task name, let's change this name to maybe 100,000, 100K subs. Thanks. By the way, the channel, I think by the time you're watching this video, we have 100,000 subscribers. I never thought that it will happen. It also means that people resonate with this hands-on content. So if you haven't subscribed, please consider subscribing. This is valuable to a lot of people. So that was the task name. Then for the description, I'll say, please subscribe. All right. This will use our script to reach out to the machine, create a scheduled task that is supposed to run immediately, and it will reach out to us. And so another thing that you need to change is this needs to be your attack IP address. In this case, I have 192.168.56.104. That's my Kali. That needs to be yours. Then the port 4443. Maybe let me just be, yeah, let me make this 44444 so that we really get the maximum chance of detection. All right. So I need to run that inside of the same folder with the environment. Okay. But before I run it, let me start a listener on all fours. All right, my listener is there. Let's run it. And if you want to run it, let's put -F so that it can append. Keep note of the name of the task because we're going to find it, and then also the description. So now let's run it. Okay, scheduled task was there. Next, someone needs to run GP update, or you can just wait for the group policy to update by itself naturally. Maybe it's every 5 minutes or so. Otherwise, we can go to the machine and run GP update force immediately, and we'll get a reverse shell. But we're going to let it run by itself. While we wait, let me show you where the group policy object goes in Active Directory. So if you go to Active Directory and you search for group policy management, I went to the domain, north, and then here's the stack wallpaper. If you want to see all the shenanigans that we were pulling, which I think is important for some people, like, hey, what was I doing when I was running those things? You can go to settings, then we can see scheduled tasks, or maybe let me close this and open it again. Group policy management. All right. And there we go. It just opened it to the same place. Okay. Here, if I go to, is it settings? All right. Now I see scheduled tasks here. All right. I see more tasks. This is the last task that we did, 100K subs. Thanks. Notice that it's right there. So we know that this is where these tasks show up. So if investigators are coming and they're trying to find out, did somebody abuse any GPOs using scheduled tasks? This is where they will be. And I haven't found a way to clean them up. I was trying to clean them up before I started the recording. That's my next task is, okay, if I want to get rid of them in a clean way without breaking things, how do you clean up after yourself? If you know that, please let me know in the description. Maybe you have done that or you have ideas. I'm curious. How do we clean up after ourselves? Because we made a mess here. Now all these tasks are showing. So this is where things are. And if our task ran, it still hasn't ran. We're still listening here. Maybe, let's do a CMD. GP update / force. You don't have to do this. I'm just doing it right now because I don't want to wait for their group policy to update by itself. But I'm just forcing it to update right now. Let's see if we get a call. Yeah, and we did. So now that we got a call, we can do something like, where am I again? Notice that it actually gave us a reverse shell, a system on the domain controller. That means that we can actually start dumping a bunch of hashes and everything that was happening there. So we got scheduled tasks created, we got a reverse shell, and we are in here as system. Let's go back to our intrusion detection system one more time before we call it quits. We did not generate a ton of traffic. So if I refresh on any of in my Kibana here, most of what we did was kind of, a little bit of traffic, but not too much. you notice that, yeah, the spike didn't even become that significant. So that's another thing to note. But we sure did ruffle some feathers on the alert section here. So let's refresh this. Maybe we'll find something interesting. New user created via net.exe. Okay, that's the user that we created last time. ET hunting, who am I command inbound on high port. Yeah, this alert here, what that means is this is the port 444. So somehow we have a playbook that says if someone runs the command who am I on a high port, please let us know. So this is actually a very interesting Suricata rule that I think people should keep. This also is only true if you're not using LDAP-S and your data is not, encrypted. So that's something to consider as well. But we can see that we did that. So that was cool from the network side of things to see. All right, looking at our graphs here, we did not spike a ton of data. I like to know like what's normal and what's not so that I can almost desensitize myself. Looking at the network here, we actually did not stand out as much. So okay, so I guess we get another where am I here as well. So we can definitely improve our detection here. But if you know better ways or more rules that we can add in here, please let me know. We're going to be enabling Tracker so we can do some file scanning as well in our lab environment. But this was really fun. I enjoy doing this. This is really fun discovery. And I'm also happy to share it with you. So thank you very much for watching. I'm going to stop it here. If you have any ideas, things that we should do in future videos, please let me know. I'm excited to be doing this with you. I'm excited to learn with you. Otherwise, have a good one.